Okay, today I want to talk about using Claude-Light. Claude-Light is a little Raspberry Pi instrument that I made. It has a red, green, blue LED you can see down here. And you can set this remotely by a web interface. So here I have it set to red to 1. We could change it to green and send that, and it will light up the LED and then give us these all this data that's measured. And you can do this in the browser. You can also use a Python API and run it through Notebook. But today I want to show you how we can use an MCP server to run this in the Claude Desktop. So there's a new feature available. So when you install this, this should be here, we can do clmcp. That's a command line tool that gets installed, and install the MCP server. So before we do that, let me just show you a vanilla, version of Claude. It looks like this, and if I ask it to tell me about Claude-Light, then it will think for a second and then tell me something that is not remotely correct or reasonable, because Claude doesn't know anything about Claude-Light. So let's go back here and follow these directions. I have already installed the MCP server, so I'll just say cl mcp install, and that does automatically installs it in this location, Claude Desktop config.json. And what this did was add this particular line right here that tells the desktop how to run the MCP server. Okay, let me restart Claude here and show you what's different is the little hammer now has 3 MCP tools available. 2 of those are from Claude-Light. So there's an About tool and there's an RGB tool, and this vSearch is another tool that I was playing around with that you won't see. So now let's ask it again. Tell me about Claude-Light. And now it's going to be able to use the tool, and it will pop up this thing that asks if it should allow the tool, and I'm going to allow for this chat. I wrote it, it's okay. And so now it tells us that it is a scientific instrument for measuring RGB values. It tells us the specific wavelengths that it has available, and then says, would you like me to demonstrate how to use that? And so let's say, yeah. Please show me how to use Claude-Light. So it's going to now go through a few more things. Now it's going to use the second tool, RGB. So I'll say allow for this chat. And it's going to set a couple of values to 1. So here it's going to set them all, and then shows us some outputs. Let's see. So it didn't really give us anything super exciting there. Let's try this. Set the red channel to 5 values and return the red light output in a tabular form. So it's able to infer that the red light output is 590 and 630 nanometers. Those are correct. And now it's running, it's even keeping green and blue at 0, which is what I wanted, but wasn't explicit in saying. So it ran these 5, and now it is generating a table, and it has set these values. We measured these 3, I guess it gave 4 outputs, and it has basically done the experiment that I wanted. So let's say plot the 630 nanometer output versus the red channel input. fill line and show some statistics. So I'm not super wild about the use of JavaScript for making a plot and doing the analysis, but I'm not doing any of that actual work, so as long as it turns out to be correct, I think that'll probably be okay. All right, so here we have the data. This data is super linear, as it turns out, and I don't love everything about the plot, but it was pretty easy to get. And it tells us the slope and the intercept, and we have a very good R squared, low RMSE compared to the outputs, maximum residuals. So it gives us quite a lot of information in doing that. So this is a overall like the most basic demonstration of an MCP server for it, and we can have a look at how it is set up. You just create a Python file, so this is in Claude-Light, and use the fast MCP server. So we make one here. We register tools like this. So a tool is just a function that gets called by the large language model by Claude Desktop. And the about tool here just returns a string about Claude-Light. That's where it got the information. And then the RGB function just takes a red, green, and blue float, and it's going to run a very simple request, and then it just returns the data. In fact, this isn't technically returning a string, it just returns the data. But type annotations in Python are not super strict. And then this is the server that gets run, so the main function is what runs the server. I gave it some sort of rudimentary install, uninstall capabilities because you have to edit that JSON file for the Claude Desktop config, and it's different for Mac or Windows. And all it does is add the server definition here for it. And otherwise, it just runs the server if you call this with no arguments. So that's the main idea. It's not very hard to write this. You can see it's not a lot of Python. You plug it into Claude Desktop, and then you can run Claude-Light from Claude Desktop. Of course, you can use functions and tools in your own Python script. It's not necessary to use Claude Desktop here. It just has a really nice user interface to put it all together. So overall, I think it's pretty interesting, and certainly could be used for interacting with other scientific instruments, and there are a bunch of other MCP servers that would allow you to do some other interesting things. So that's it for today. I just thought it would be fun to show that you can run my little Claude-Light instrument remotely from an LLM with this recent MCP capability of Claude Desktop. Thanks for coming. See you next time.